Lesson 12.3, Surface Area of Pyramids and Cones. A pyramid looks something like that. All the faces except one intersect at one point called the vertex. It's the vertex. So you see that face, that face, that face, and that face. They all intersect up there. The only one that doesn't intersect up there is that one, which is the base. So the base is the face that does not intersect in the vertex. The lateral faces are the faces that do meet in the vertex, and they're going to be triangles. The lateral edges are the edges that meet in the vertex. So there's a lateral edge, lateral edge, lateral edge, lateral edge. The edges around the base are then called base edges. The altitude is the segment that goes from the vertex and is perpendicular to the base, otherwise known as the height. So altitude and the height. Altitude is technically the length of the height. Height's perpendicular to the base. And then slant height is along the surface. A regular pyramid, a base is a regular polygon, and the vertex is directly over the center of the base. In a regular pyramid, all the lateral faces are congruent isosceles triangles. The height of each lateral face is called the slant height, L. Our lateral area is 1/2 perimeter times the slant height. How do we get that? You say, let's take a very simple pyramid and let's draw the net. So this is a square pyramid. These sides are your lateral faces. So area of each of those is 1/2 base times height. But I would end up multiplying by the number of sides of the base. So in this case, it would be times 4. Well, 4 times the length of one of these bases is known as the perimeter. Hence, it's 1/2 the perimeter times the height. The height of one of the lateral edges is the slant height, L. Surface area of a regular pyramid, it would be the base plus the slant height. So surface area is base plus 1/2 perimeter of the base times the slant height. Slant height's the one on the surface. Find the surface area of this regular pentagonal pyramid. Well, I need to know the area of the base. It's a pentagon. Remember, finding the area of a regular polygon is 1/2 the perimeter times the apothem. Conveniently, they're all labeled. That's the apothem. This is the edge of a base, so that means our perimeter is going to be 8 times 5, or 40, because there are 5 of them, and they're each 8 long. So the perimeter is 5 times 8. The apothem is 5.5. Plug those in, and you get 110. We need to know the slant height. The slant height would be right there. We could use the Pythagorean theorem to find that slant height. So a squared plus b squared equals L squared. Oops. So our slant height turns out to be 7.3. So our surface area is the area of the base. There's only one base, that's why it's only just a single b. Plus 1/2 the perimeter times the slant height. So our base was 110. The perimeter was 5 times 8. Slant height was 7.3. Plug it in, you get 256. Cones. Cones are like pyramids, except the base is a circle. So anything that's base would be, area of the base is pi r squared, and the perimeter of the base would be the circumference 2 pi r. So our lateral area, how did that happen? It was 1/2 the perimeter times the slant height. So it'd be 1/2 pi 2 pi r, because it's a circle. Oh, but what's 1/2 of 2? They cancel out, so it's just pi r L. And the surface area of a cone is the area of the base, which is pi r squared, plus the lateral area, pi r L. Pi r squared plus pi r L. So this is r, area of the base. This is 1/2 the perimeter of the base times the slant height. The So Good ice cream company makes cluster cones. For packaging, they must cover each cone with paper. If the diameter of the top of each cone is 6 centimeters and the slant height is 15 centimeters, what is the area of paper necessary to cover one cone? So I have to decide what part of the cone are we covering. Everything? Just the base, or just the lateral area? Well, if they're going to stack like the picture, we would cover just the lateral area, just this part of the cone. So lateral area is pi r L. What do we know? Well, that 6 centimeters says is the diameter, so that means our radius is 3 centimeters. And we know our slant height right there. So we fill in the 3 for the radius, 15 for the slant height. Multiply together, you get 141.4 centimeters squared for each cone. That's all for today. Have a good day.